Okay, so we're going to now practice what you learned about using your calculator for these problems for these next examples. Okay, so we are looking at €1,000 is being invested in an account that pays compound interest at a rate of 6%. Calculate the amount of money in the account after 10 years when the compounding is annual, quarterly, and monthly. So the thing that's changing here is how many times it's compounding. So keep in mind, TI-84 versus TI-Nspire is different, but whatever inputs that you have that deal with compounding, those are going to be the inputs that change. So if I were to put together this formula, which if you know how to put together the formula and you know how to use your solver, if you have a TI-Nspire, that would be another way to use your calculator to help you out. So we want to know how much the amount is left over. So we want to know what the final value is at the end of all of these guys. So final value equals the present value. In other words, the initial value of 1,000 times 1 plus, we have a 6% interest rate, divided by 100 times the number of compoundings. Since it's annual here, there's only one compounding. And then we're talking about one compounding again at the top times the number of years, so 10. I'm actually going to use my finance solver on my calculator to do this. Don't forget that when you put in your present value, it should be negative 1,000, not positive 1,000. And I'm going to cross-reference to make sure that I'm using the calculator correctly so I don't lead you astray. Good. Awesome. Okay, so the final value that you should be getting is 1,790.84 euro. If you did not get that, give me a call or Google some more about how to use the calculator and double check what you're plugging in where. With TI-84, I'm pretty sure with changing the compoundings, it changes your N. It also changes your P/Y as well as your C/Y. So there's a lot of things that compoundings change. Whereas with a TI-Nspire, the only thing that changes is your CPY. Which is towards the bottom. Okay, quarterly. So the thing that I'm changing here is that it's being compounded quarterly, which means it compounds 4 times. To find my final value, fantastic, 1,814.02 euro. Should be the answer there. Versus monthly, that means that your number of compoundings is 12. Scroll up to your final value, press enter to get the new value, and we get 1,819.40 euro. So stop right now. If you are not getting the same thing as what I am getting right now, that means that you are still unclear on how to use your calculator. There are many options available to you. Giving up is not one of them. So give me a call or Google or reach out to a friend and see if they're getting the right answers on their calculator. If nobody's getting the right answers on your calculator, then definitely give me a call, because then maybe I didn't explain something correctly. So definitely use me and all of the resources that are available to you right now. Okay. Helena puts 15,000 euro in a bank account earning 6% annual interest rate compounding monthly. How much interest will she have earned over 20 years? So I need to put in, her initial value. So we want to know how much she earns in interest. So that's a really key point here. How much interest will she have earned is not how much total she will have earned. It's how much more she will have earned from the original amount. She originally put in 15,000 euro. And the idea is that, well, yeah, she already had that 15,000 euro, but interest that she's earning is free money that's just being given to you for not touching this money, which is great. And that's the whole draw on this, is that the bank is giving you free money. And so how much interest she has earned is not the 15,000 euro, but the amount that's being put back into the 15,000 euro. So what we're going to do is we're going to find the final value and then subtract out the original 15,000 to figure out how much did she earn over a course of 20 years on the initial value, which was 15,000 euro. So we're going to find our final value, but then subtract out 15,000. So I might write a note to myself. Interest equals final value minus 15,000. Okay. So my final value is equal to my original value times 1 plus my interest rate, which is 6% over 100 times the compoundings, and it compounded monthly, so that's times 12, to the 12 times 20, because that's over 20 years. I could type this all in, or I could use my financial solver, make sure that I plug in negative 15,000, still a 6% interest rate. My number of years is 20. Compoundings is still 12. So then I go to my final value and I get €49,653.07. So in order then to find out what my interest is, I need to take that number and subtract out 15,000. Seven minus 15,000, and I get 34,653.10. I think it's because significant figures, that's as much as my calculator was going to give me. But I want you to take a second and look at that. That is more than double the amount that she originally invested just by letting it sit in a bank account for 20 years. 20 years is a long time, longer than you all have been alive. It's most of my life. So it's a long time to let money sit, but that's over 30,000 euro. That's just free. Okay, you want to invest 1,000 euro. What interest rate is required to make this investment go to or grow to 2,000 in 10 years if interest is compounded quarterly? So the thing that we don't know here is our interest rate. So our final value, we want our final value to be 2,000. If we originally invest 1,000, plus this interest rate that we don't know, divided by 100 times the compounding quarterly, means 4 times per year. And then you're compounding up top, which is 4 times the number of years, which is 10. Now, this is a lot to do algebraically, or we can just use our financial solver in our calculator. So the number of years is 10. The interest rate we don't know. Initial value, so we do a negative 1,000. Our final value will be 2,000. Compounds are 4. So then I get to scroll back up to the interest rate and press enter on that guy. And that should give me an interest rate of, double checking, yes, 6.99%. It is always a good bet with these problems with the IB to fill out the formula at least and show them that you know what you're talking about and not just give an answer, because if you just use your calculator and just give an answer, the IB will be like, we don't know if you actually know what you're talking about. So definitely make sure that you're filling out the formula, and since it's in the formula packet, it's good to go. All right, the next two examples are to show you that you can actually still use this calculator and this method to TI-84 or TI Nspire in order to solve for things that aren't technically interest or financial issues, because it follows the same pattern. So if we're talking about any sort of depreciation or growth percentage-wise, this is a good way to go. The city of Baden in Lower Austria grows at an annual rate of 0.35%. The population of Baden in 1981 was 23,140. What is the estimate of the population of the city for 2025? So we don't know what the final value is here. So we can set it up just like we've been setting up our interest rate, our financial stuff. So final value is this guy. The initial value was 23,140. 1 plus 0.35, since it is 0.35%, divided by 100. Compoundings is 1. And then 1 times, and then what's 25 minus, 2025 minus 1981 is 44. So using your financial solver to plug in all of these pieces, 44 for the number of years. If you have TI-84, it would still be 44 because it's only one compounding. So it'll be 44 times 1. If you have a TI Nspire, don't worry about it. Interest rate is 0.35. Still a negative in terms of your initial value, negative 23,140. Final value, we don't know what that is, so we should be deleting that guy out. Compoundings is still 1. So then now we get to go to the final value. And we get 26,985.34. We don't have a percentage of a person. So we will round accordingly, which is down. And that's how many people should be in the city in 2025. So you've just set up a population, which is a percentage increase, which makes sense. You know, if you have bunnies that replicate or duplicate every year, right? You're taking double of that amount every year. It's the same with humans, just at a smaller rate. So instead of doubling every year, we're multiplying by 0.0035 actually, but we're by 0.35%, they're growing every year. And so that is just like a percentage growth problem. And so people behave the same way.